Hey everyone, welcome to this channel. In this video, we are going to talk about a new lead code problem, which is subarray product less than k. Right. So in this problem, we are given an array of elements, and we are also given an integer k. Right. We have to return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. Contiguous means continuous, there should not be any break in between, right? So suppose we take the first example 10, 5, 2, 6. So and the k value is given 100, right? We uh, we check for 10. So yeah, 10 is less than 100, so it is in the answer. Then we check for 5, 10 combined. So 10, 5, 50, which is the answer here. And also 5, it is also less than 100, so that is also in the answer. Then we include 2, so 10, 5, 2 is equal to 100, so that will not be the answer, right? But with the addition of 2, 2 will be the answer because it is less than 100. And also with the addition of 2, this 5 2 which is equal to 10 is less than 100, and so that will be the answer here, right? So then we go to 6. Then with the addition of 6, 2 6 6 which is less than 100 will be the answer here in the answer. Then 2 6 which is 12 less than 100, so it will be in the answer. Then 5 to 6 combined, it will be 60, which is less than 100, so that will be the answer. In total, we are having output as 8 elements are the 8 combinations are the answer. So here we can say c k is equal to 0, it's not in the answer, right? One thing we have to make note of is all the elements are greater than 1, greater than or equal to 1, okay? And k can be equal greater than equal to 0 to 10 to the power 6. So if we talk about this statement, in this statement, k, if k is equal to 1 or if k is less than equal to 1, it means that we need the element of the array which should be less than 1, right? But here all the elements are greater than equal to 1, so we cannot have any element which is less than 1, which contradicts here. So k cannot be less than equal to 1, because if it is less than equal to 1, even if it is equal to 1, we will need an element which is less than k, which is less than 1, but it is not possible with this constant. So we can straight away write here, right, such less than equal to 1, we will return. How we are going to approach this problem? We are going to approach this problem by the two pointer approach, which will be moving as per one condition. Then we will store answer as 0, okay? And we will take a loop, right? So this is the second pointer. We will also take uh, one thing I want to explain is that here we will need one concept, which is if there is an element 5. All right, so what will happen is we will have a count as the number of element as 1 due to this 5. If we add an element 2 here, then there will be two additions. One is this element 2 and one is this combination 5 comma 2. So it will be 1 plus earlier, which was 1, which was only 5 as the combination. Now it will be having two more combinations. And then if we add one more 3, so there will be three additions of the combinations, which are 3 itself, then 3 2, then 3 2 5, and 5 2 3. So three additions. So total it will be 6 additions with the help of these three numbers. So we will be needing this in this concept. So first we will take left pointer as 10, All right. This is left. 10 is less than 100. If k is equal to 100, then 10 is less than 100, so it will be there in the count will be 1, which is the answer. Then we include the right was also there, but now the right will come here. So uh, so 10 5 with the addition of 5, it will be 50, which is less than 100, so we'll include this 5 also. Then with the addition of 2 here, what will happen? 10 5 2 will become 100, which is equal to 100 and not acceptable. So we cannot add 2 here with along with 10 and 5. So what we will do is, we were taking 10 5 2. Now we will deduct this 10 and we will only take into account as 5 2, that whether this combination is acceptable or not. So yeah, 5 2 will remove this by incrementing left. Okay, earlier left was at 10, now it will be at 5. So 10 is less than 100, so yeah, it will be acceptable. So here with the addition of 2, 3 will not be added because 2 will be added, and 2 plus 5, which is equal to and 2 and 5, so total 2 combinations are added here. So right, 100, yeah, okay. So then we will go to 6, right will go here. Okay, so 6 is 5 to 6 is less than 100, so due to the addition of 6, 3 elements will be added, 6, then 6 2, then 6 5, so 3. So the answer will be 1 plus 2 plus 2 plus 3, which is equal to 8. All right. But if we take an example like 10 5, then 2, uh, not 2 basic. Okay, let's instead of 2, let's take 100. All right, and 6. So earlier L was here, R was also here, so uh, 10 will be accepted. All right, then we go to 5. All right, so 50 is also accepted, so we'll add 2 here. But when we go to 100, it becomes when we go to 100 as R, then it becomes 5000, which is not acceptable. So we'll move L from here to here. Now L will be at 5, right? So L will be at 5, so 500 will also be not acceptable. So we will move this L from here to here. Now 100 divided by 100 will be 1, so that is acceptable, right? Sorry, not 100 divided by 100, it will be 5000 divided by 100, which will be 50. Sorry, it will be 100 divided by 100, as we have divided already on this 50, so it will be 1, so it will be acceptable. So 100 will be added, then right will be here, right, and it will be 600, it will not be accepted, so we'll move L from here to here. So 6 will be added of this one, so it will be 5 answer, 5 as the answer. Let's code it. So we have calculated the product. We'll do while loop if the product till now is plus 1. All right, so okay, what is the okay, colon has been added here by mistake, prod into num side, it will be right here. It will be nums left plus plus. It's running now, right? Yeah, it's running. So time complexity will be like it is going, iterating the whole loop. So and space complexity will be over. So that's it from this video. If you like this video, please like and share this video, and also subscribe to this channel.